I have 3 of them in the back over there underneath the calculators for you, Olivia. So if you need to move around to plug it in, feel free. All right, let's start. All right, again, it says review for quiz 3 on Classroom. You can open that up, and this is what you see. If you don't want to take notes, you don't have to either. I just want to at least give you everything that's on there tomorrow so you can try to be successful. 3 theorems I need you to be aware of tomorrow. 3 theorems are facts. More of facts, probably, because we're not doing any proofs. First one involves when 2 chords intersect. All right, so if you want to plop a center in this first one here, make a center on this first circle. And then draw in chord AB, however that looks, chord AB. And your second chord CD, make sure it intersects chord AB. So I need these 2 chords that intersect, AB and CD. Both intersect each other, and they intersect at point E. Remember, there is nothing on Circle Quiz 2 on this quiz, so I don't care about finding this floater angle. That's not useful for you tomorrow. What I need is, how do I find the length of CE? How do I find the length of AB, ED? When 2 chords intersect, I'm going to ask somebody right now, if you forget, you're going to open up your packet and remember. What's the theorem? Or using these letters, what do you do when 2 chords intersect? Okay, what do you do when 2 chords intersect each other? All right, so for instance, say you know all 4 values and one of the 4 values is X. All right, so I label all 3 with a number and the 4th one I label with X. What would you do to find that missing piece? In your own words or using the letters? Let's start this off right. There we go. Charlie, what are you going to do? Yep. There you go. So I'm going to take 1 chord, which is broken up into 2 parts. AE and EB, I'm going to find their product. Good. And then obviously you know that, so I'm not going to ask the rest. And then I take the other 2 chords, or the other chord, which is broken up into CE and ED, and find that product. It's kind of like mean. Remember, product of the means equals product of the extremes. That's where we got that one from. Right, so that's 2 chords only. I made a blank here. I didn't know whether or not to actually draw it in, but I just want to, this is just kind of a reminder that this theorem also applies to diameters in chords. Because what is a diameter? Longest chord in the circle. Yeah. So just a heads up. Again, you don't need to, I don't think it's necessary to have it, but just as a reminder. Same thing applies. That theorem Charlie started giving us, same thing. AE, watch, ready? AE and EC, everyone sees where that's coming from. The chord getting bisected. Intersected, not bisected. The chord getting intersected. Now what about the diameter? What are the 2 parts here? Well, BE. And then what are we going to multiply with BE? Because that's why specifically I put that center in for you to fall into the trap. You're not multiplying it times EO. It's going to be ED all the way through. All right, same fact, just 2 different looking diagrams, but same fact. Questions on that fact? All right, fact number 2. Secants and tangent lengths. Secants and tangent lengths. So for this diagram, I'll do a secant and a tangent, but remember, you can also, this also will apply to 2 secants. Right, this also will apply to, I don't want to do a different diagram or multiple diagrams on this one. So this is, I'll put secant. Okay, we'll come back to that in a second, it looks like. Just when I'm on fire. Let's try that again. All right, back to my talk here. We'll call this secant ABC, and we'll call this tangent CD. What is the expression or using the letters. How do you find the tangents and the secant lengths? Tangent and secant lengths. What do you got for me, Zeev?
It was a CD times CD.
Okay, well that's the tangent part. Yep.
Equals CA times CD.
Yep. Whole times external equals whole times external. That's the saying we had. So CA whole secant times the external part. And Zeev mentioned already that, hey, when you do a tangent, whole and external are the same, right? Whole and external are the same. Again, also works for two secants, right? Also works for two secants. Two tangents we don't need because they're already congruent based on the party hat theorem. Two facts, good so far before we get to the final one. Everyone's going to forget this final one, so that's why we are going to review. In the final fact, you have two chords which are parallel to each other. So go ahead, draw two chords that are parallel. They do not need to be congruent. They just need to be parallel to each other. Two chords parallel to each other. What is that? So let's finish this. Given parallel chords, that implies, what do you have now? Two chords are parallel. What do you have on your hands right now? Two parallel chords result in Doyle.
Arcs BD and AC.
Nice job. The arcs in between. Make sure the arcs in between, not the ones on top of them here. The arcs in between are congruent. So congruent arcs, which would be, yes, good job, Doyle. Arc AC, congruent to arc BD. So there's your three facts for tomorrow, everyone. Three facts. Anything you want to ask before I get to some other stuff on the quiz? Because this is part of it. Looks good, those three facts. Okay. Let's go to one construction. We did 4 on Friday, so it's going to be one of those 4. I'm not going to play around either. All right, it's not going to be like a tricky one. It's just going to be, this is what I want you to do, done. So it could be what? Let's list out all our possibilities from Friday. Could be what type of circle construction? Construct A. Start us off, Josh. Construct A.
Like a hexagon.
Okay, hexagon. Could ask you for a hexagon. Yep. All right, could be a hexagon. Maybe not. Could be a. Ooh, Zoe. Equilateral triangle. Perfect. I'm glad you two said those two specifically first, because I'm going to group these together because what do you know about them? They're same exact construction, except at the end, hexagon, you connect every arc. Equilateral triangle, you connect every other congruent arc. Yep. All right, well, maybe I'm not feeling those two tomorrow. I could ask you for what else? Ooh, Aiden, what else could I ask you for? Tangent line, yep. Construct a tangent line. I like that one. And if I don't ask for any of the three, it's going to be a, Amy? Square, diameter bisected. All right. One quick discussion point here. In your review, I don't have any construction practice. I don't need to. Here's why. Here are the steps to practice constructions. Ready? Here are my steps. Step 1, grab a piece of paper. Step 2, draw a circle on it with the center. Step 3, pick which one you want to do. Step 4, do it. That's how you practice the constructions. I do not need to print out 2 pages worth of here's a circle, here's a circle, here's a circle, here's a circle. Do this. You can do that on your own. The only thing, if you're going to practice a tangent line, yes, you do need a circle in a center, but make sure you put an extra point on there so you can draw your tangent line through. All right, so grab a piece of paper, draw a circle, do it. Okay, that's how you can practice if you want. I know that sounds rough. All right, circle equations, big part of the quiz tomorrow. Circle equation, x minus h squared, right, plus y minus k squared. There's the center radius form, and there should be 3 numbers plugged in, or you will plug in 3 numbers into it. First 2 numbers for h and k. You'll plug a number in for h or take it out, and you'll plug a number in for k or take it out. When you put the 2 together, you have found the what here? What does h and k represent in that circle formula there? Will? That is the center, hence center radius form. And we'll have a value right here in for r squared. Great number. Probably not going to be what I need. I need the r value though. And that r value represents, what do you got up there? Will, again, circle formula hero. Radius length, yes. You ready to factor? I believe it was Zeev asked on Friday. What I have you factor is factorable. You will be able to multiply 2 numbers that multiply to C and add to B. If you're uncomfortable with factoring, you feel a little awkward, I'll have quadratic formula on the formula sheet attached if you'd rather use that instead of trying to factor it. But everything will be factorable. And I do not want to blindside you. I didn't write this down, but I don't want to blindside you. There are 2 other formulas that you'll need. This one will be given to you if you need it. The other 2 will not be given to you. And shocker, what one of them is going to be. Distance. And you're going to need the midpoint formula tomorrow. Oh boy. What's he doing? Not given. Never will be given. Never has been given this year. But you will need those 2. Want a quick discussion on why we would need the midpoint formula? What if I gave you the diameter? What's the midpoint of every diameter? The center. That's pretty useful in this unit, huh? Okay, so that's probably where you would need the midpoint formula. Given a diameter, the midpoint would be the center of the circle. Okay? And then we're going to do one here in a minute, completing the square to go from standard form to our center radius. To put it in there, we'll go over one in a second. And since I'm not going to be after school today, there's extra review up on Delta Math I put up there in addition to your packet. Questions, comments, any concerns for test quiz? Sorry. Quiz 3. Quarter 4, by the way, we only have this quiz 1, 2, 3, 5 tests / quizzes. That's it. That's all we have for quarter 4 is 5. All right. Next unit only has 1 test, and that's it. Make them count. All good? Anything you want to ask before I do a completing the square problem? Hey, back to your packet then. Here you go. Number 10. Back to your packet. Number 10. Let's do a little completing the square before I let you guys choose your own adventure. Haley, you should also know I believe you received 3 votes today. You received 3 votes, yes. And Junie had 6, maybe 6 or 7. All right, ready to roll? All right, let's do this, kids. I picked the most disgusting looking problem I could find right off the bat. All right, because that is a hot mess, that equation that I need in the center radius form. All right, I need your help. First, we need to reorganize this thing, don't we? All right, what's your first step going to be up here in reorganizing it? Put your X's together, put your Y's together, and that constant, that number without the variable, make sure it's on the other side away from the X's and the Y's. So go ahead, take your time now, do some moving around here. All right, once everything is grouped together, the constants on the other side, I could have really done this in the same step, but I just want to show you guys separately, step by step. Now I find my new C value for the X's and the Y's. This is where you complete the square. And notice every time I put a blank for my new C value, there's always a plus sign next to it. Your C value is always positive. We've talked about this. You square any type of number, it's going to be positive. All right? So always positive for your C value. And I just put away my numbers. So quick reminder. Actually, you know what? Maybe I'll do. Let's see if see how my memorization is here.
Yeah.
No, I'm going to butcher it big time. I can't even find the darn numbers on there in enough time. Ah, Doyle. Look at that. Because I called on it already today. How do you find? Don't tell me. How do you find the B value? Or C? Sorry, C value.
You divide the B value, then square it.
There you go. Good job. Divide your V value by 2, then square it. All right. So what's my new C value with the X's here? What's my new C value with the X's? Aiden. 16. What's my new C value with the Y's here? With the Y's, kissing you.
9.
9, good. Come on, don't. Here's what I told third period. You do this tomorrow. You leave it like this. I'm coming to 6th, 7th period, whatever you have next, headlocks. I'm just coming right in and putting you in a headlock. All right, if you leave this thing unbalanced tomorrow. All right? Kids are just going to be going nuts in class. What is he doing? So you know tomorrow if I come in, you forgot to balance the equation. All right, now it's factoring or remembering the trick I showed you. I'll go over the trick after I'm done here, though. What do we get over here? 64. All right, what's going to go in this first set of parentheses? 2 numbers that multiply to 16 but add to -8. 2 numbers that multiply to 16 and add to -8. In
-4.
-4. They should both be the same every time. I can't write it like this unless both numbers are the same. Plus 2 numbers that multiply to 9 but add to 6. Multiply to 9, add to 6. There's my Gabby. No, nope. You're 15.
Yeah.
There's my kryptonite right there. The double, like 10 through 14 is my kryptonite.
You're not 10.
Gianna? All right, what do you got?
3.
And just because I heard that here, I'm not going to pretend I knew that. 3, good. Again, the trick, just divide your B value by 2. Divide your B value by 2. All right, center and radius here. Center. I have a feeling. Will, is that you? Nope. Who? I don't know. Thomas. Yes? Okay, there we go. What do you got? Center? 4, -3. You can just do the opposite. Radius. Gianna. 8, not 64, right? I tried to set you up for that one. This is R squared, not the radius length. So it's 8, yes. Questions on completing this? And it might not be multiple choice tomorrow either. It might just be, hey, what is the center? What is the radius? All right, so make sure you balance it. All right, you have 3 things you can do right now. Keep going in your packet. Keep going in your packet, and the answer key is on page 63. You can go to Delta Math, or you can grab compass, straight edge, and a piece of paper and practice your constructions. 3 things you can do. I don't care who you work with. You can move around as long as it's on one of those 3 things only.